do this one we'll do together now. Okay. All right, so for this one, again, you had to, divide, and you also have to simplify, okay? So for this one, to divide, just like with regular fractions, okay, what you have to do is you have to take the reciprocal, which basically means, of the second rational expression, which basically means you invert, you flip the second fraction, okay? So the denominator becomes the numerator, and the numerator becomes the denominator. And then you're going to multiply. Okay? That's what happens. And when you multiply, we have this. Now, since we're simplifying, I wouldn't carry out the multiplication because you're going to have to factor anyway. Okay? So what we want to do is instead factor this numerator and the denominator. That's what we're going to do. Okay? Just want to make a note to this. So that's what we're going to do here. So we have x squared plus 21x plus 20, right? So I'm going to factor this denominator first. So again, notice there are three terms. Degree is 2. Leading coefficient's 1. Okay, so we want two numbers then whose product is the constant term, 20, and whose sum is the coefficient of x, which is 21. So we want two numbers whose product is 20 and sum is 21. Okay, so what numbers do that? 20 and 1. I mean, even if this wasn't here, you should have seen that. But once you get the numbers, you put them in like so. For the next one, this numerator, x squared plus 7x plus 10, right? We have two numbers whose product is 10, the sum is 7, right? Because again, this is a trinomial, 3 terms, degree 2, leading coefficient's 1, okay? So two numbers whose product is 10, but the sum is 7, so 5 and 2, and that's why we got this. For this here, 2x minus 10, right? Well, this is degree 1, but we do see that 2 is a factor of 10, so let's factor out 2. That's what I'm doing here. You divide into each term. We get 2 times x minus 5. So we have factored those. X minus 2 is already factored. So if we put those in, right, and then we can multiply like so, and really you can't cancel anything, so it's actually already factored. I mean, we probably could have checked that using, quadratic formula and the factor theorem. That is, we could have seen what the zeros of this polynomial are, what the zeros of this polynomial are. Same thing here. But, factoring wasn't that bad here. It's already simplified. And again, we're multiplying or dividing two rational expressions and simplifying so we can leave the answer like this. Okay? There's nothing else we have to do. I hope that made sense. Are there any questions on this? Okay. What we can also do is we can also consider how to add and subtract rational expressions. Just like with fractions, right? We can add and subtract rational expressions as well. Just like with fractions, though, you have to have a common denominator. Now, there's really many choices you can use for the common denominator, but the best choice, though, is the least common denominator. That's really the best choice here, okay? So that's really the best choice here, the least common denominator. And by definition, That's the polynomial of smallest degree that contains the denominators, each denominator as a factor. That's just what it is by definition. Okay? That's just what it is by definition. To find it, I have this process here. So, you factor each of the denominators completely. You keep factoring until you can't factor anymore. You're going to list each different irreducible factor from each polynomial. You're going to list each different one only once. Sometimes sometimes the denominators could have a common factor, but you only list it once though. Then you determine each factor's largest exponent, what it's raised to. Then you're going to raise each factor to the largest exponent and then multiply. I know that sounds very confusing. You're probably thinking, what is he talking about? Again, we'll do some examples now, and it should be clear from that. So let's do some examples. So let's find the LCD for these two. We're not going to add or subtract them. All we're going to do is get the LCD. Okay. All right. So here, it's a little bit easier because the denominators, they're already factored. Okay, that's good. So here we have x minus 1. That's an irreducible factor. Put that here. We have x plus 2. That goes here. We have x, right? That's an irreducible factor, so we put that here. It really doesn't matter what order you list these. So x minus 1 is listed already. X plus 2 is listed already. Okay. Now, what we're going to do next, here is we're going to determine the largest exponent of each factor. So for x minus 1, we have 1. We have a 2 here as well. So 2 is the largest exponent. For x plus 2, we have 3 and 1. So 3 is the largest exponent. For x, right, the only exponent is 1, so we list 1. Now, what do? We have x to the first times x minus 1 squared, right? We're raising each to the largest exponent. X to the first times x minus 1 squared times x plus 2 cubed. So that's what we get here. Okay? Now, we don't have to write the 1 because, again, the exponent that is, because, by convention, people don't write it. If you did happen to write it, that is, if you did happen to write it as x to the first, I'm not going to take points off. That's fine. So, are there any questions about this example? Okay. For this pair, notice that the second rational expression is factored. The first one, we have to factor it. Okay, so let's do that. So notice that x squared is the smallest power of x. So we can factor that out. We have x squared, right? How do we get what's left over? We divide. That's what I'm doing here. Okay, so from here, we're going to get x squared times x to the fourth over x squared, right? We divide into each term. X to the fourth over x squared plus 3x cubed over x squared, okay, minus 4x squared over x squared. And that's going to be x squared times x squared plus 3x minus 4, right? Again, you subtract the exponents. But now we really want to factor this completely, so we're actually not quite done. We have to see if we can factor this. X squared plus 3x minus 4. Okay, that's good. So let's do that. Okay. So notice it's a trinomial. 3 terms, degree is 2, leading coefficient's 1. So we would want two numbers whose product is -4, but the sum is 1. The sum, excuse me, is 3. What am I saying? The sum is 3, right? The product would be the constant term. The sum would be the coefficient of x. So we have x plus, so what numbers would do that? Well, how about 4 and -1? You know, the product of those is -4. The sum is 3, so 4 and -1. So those are the numbers we'll use.